Okay, this is the first revision video for P1 and we're going to look at transfer of energy. So, starts off with all of P1 talking about infrared radiation. So, all objects will emit and absorb infrared radiation, which is heat. Okay, the hotter the object, the more infrared radiation it will radiate. So, if you've seen police shows and the police helicopter, looking at a person running across a field, they'll be sort of more red or white, so giving off lots of infrared radiation compared to the surrounding areas, which will be far more blue in colour because they're much cooler in comparison to that hot object. Okay, you need to be aware that dark or matte surfaces are good absorbers and emitters of infrared radiation, whereas light and shiny surfaces are poor absorbers and emitters of infrared radiation, but they're really good reflectors. So you might notice if you're on the beach or in the sea, the light, the light sand will reflect that sun's radiation back to you. Okay, whereas dark matte surfaces, if you go outside on a warm day and you're wearing all dark clothes, get ever so warm because it's absorbing all that infrared radiation. Okay, so be aware of the two types of surfaces and whether they are good or poor absorbers and emitters, but remember that the light shiny are very good reflectors of infrared radiation. Okay, right, then goes on to thinking about particle models of solids, liquids and gases, and then the transfer of energy through those by conduction, convection, evaporation and condensation. So if we draw out the particle models for solid, liquid and gas, they look very familiar from Key Stage 3, but we need to remember is that a solid has very little energy. It will just vibrate when it warms up and that's it. Whereas as you go towards the gas, it gets more and more energy and those particles are going to be whizzing about and filling the container that they're in. Okay, so loads of energy, not very much energy. So what we need to think about is how heat is transferred through each of these different substances. So if we look at conduction to start off with, conduction happens in solids. So we're looking here where, say for example, a metal rod, and we're peering inside, we're heating one end of that rod and that heat's going to travel down. We know if we were to heat something, and we hold it in the fire, then our hand's eventually going to get really hot, particularly if that's a metal, because it'll be a very good conductor of heat, whereas non-metals are pretty poor, so your pans tend to have plastic handles, so it doesn't conduct the heat down to you. So the way in which this works is that the solid is in nice neat rows sitting inside, and these are all metals. And if you think to chemistry a little bit here, we know that metals are in group 1, 2 or 3 as a periodic table, so they've got 1, 2 or 3 electrons in their outer shell, and in order to form full shells, those free electrons are all moving about, all those electrons in their outer shell are all moving about inside that solid. Okay, and those free electrons can move. The atom itself, the metal atom, can just vibrate a very small amount when it's heated, but these free electrons can move and they're all free to move wherever they want. So as we heat it, they gain more kinetic energy and they transfer that vibration from the atom where it's getting heated, and they transfer that all the way down the metal. Okay, so that's conduction. You need to be able to use that term free electron when you talk about conduction. It's really important. So it's that electron in its outer shell and it's moving at a speed, and from the vibrations here, from the atoms, from the heat, and it pushes those free electrons and they transfer that heat down that metal rod. Okay, right, convection then. Convection happens in liquids and gases only. Very important to remember, okay, because the particles have to be able to move, and we know in a solid the actual atom itself can't move. So if we think about it, if we have a point of heat, so this could be, in this case, a Bunsen burner, it could be a radiator on a wall. Okay, they do prefer to do sort of radiator type diagrams in your exam. So as we heat it, the little gas particles here, or the liquid, either or, are a little bit further back and able to move. So gain kinetic energy from the heat energy, so type of energy transfer, heat into kinetic. They move more, move faster, so they spread out and become less dense. Okay, and as they become less dense, they rise and then they get cooler away from the source of heat, they lose some of that energy. Okay, so they start to fall in a bit close together. They haven't got as much kinetic energy anymore, so they become much denser, much more densely packed. So they're therefore heavy and they fall. And then it cycles all around again. It'll go back to the heat source. It will get more heat, get more kinetic energy. They'll move faster, they'll move further apart, become less dense and rise. Okay, so you need to remember that sort of process. You need to talk about density and you need to talk about energy. And then lastly, you need to be aware of evaporation and condensation. Now, you're probably aware that evaporation is from a liquid to a gas. When you're boiling your pasta or boiling your kettle, all that water turns into water vapour. And condensation, when you've had a shower, then all that hot, all that steam is gas turning into liquid when it hits a cold surface, which might be your bathroom mirror. So here the liquid is going to gain in energy. Okay, so as we heat it, it gets more heat energy, more kinetic energy, and sometimes it has enough energy to actually leave that liquid and come off as a gas, whereas the opposite happens with condensation. It hits that surface and it loses its energy, okay, and it turns back from a gas into a liquid because it's lost that energy. Now, a couple of interesting points to note here that you might need to reference in a longer answer question. So the rate at which an object transfers this energy, okay, depends on the surface area and the volume. So if we had a really big mirror, then it would lose more energy more quickly. The material it's made from, so again, if this was colder, more would condense faster because it would take the energy out of that gas. And the nature of the surface of the object is touching. Okay, so it depends on what it was that it was touching. If it was something warm, it's not going to lose very much energy, not going to get much condensation. Again, if it's cold, then it would speed it up. And finally, and you're probably familiar with this from your ISA, the bigger the temperature difference between an object and its surroundings, let's think a hot cup of tea on a cold day, the faster the rate at which energy is transferred by heating. So this is basically saying that if it was a really warm cup of tea and in a very cold day, that mug of tea is going to cool much faster because you've got a much bigger difference between the mug and the cold temperature outside. Okay, so the bigger temperature difference between an object and its surroundings, the faster the rate at which energy is going to be transferred by heating. So we've looked at infrared radiation, good and bad surfaces, solid, liquid, gas, and the relative forms of energy they've all got. Conduction, convection, evaporation, and condensation as processes. Remember, process tends to end in T-I-O-N, a type of process. These are all processes, so like combustion. Okay, the rate at which an object transfers energy depends on these factors here, and the rate of energy transfer being increased if there's a bigger temperature difference between the object and the surroundings. Okay, so that's the end of the first revision video for P1.